So today I will be solving first six problems of Codeforces round 918 rated for division 4. So let's start with problem number A. The name of problem is odd one out. So in this question we have to tell them what is the number which is occurring only one time and rest of the number are occurring two times in the array. For example, my 1 is occurring only one single time and my 2 is occurring two times. So how to find this answer optimally? So in a single line you can find this answer. So how you will come if most of you maybe done it using a map by making a count of these numbers and finding the minimum one. But this is a simple or a single line solution of this problem. So let me show you why. You know that XOR of two numbers is zero. For example, if I look x XOR x, this is equal to zero. So I can simply take the XOR of all three numbers and the remaining answer is my answer. For example, XOR of 1, comma 2, comma 2 should be equal to 1. So this is a problem number 1. Let's now discuss problem number B. So in problem number B, we are given a 3 into 3 grid, and what they have said, my each row should be containing at least one A, one B, and one C. My each column should be containing at least one A, one B, and one C. So what they have said, and but one of the characters got missing from this matrix, and we have to find that number. So how to find that? Maybe most of you thinking it could be require a most typical implementation part, but it is not. Let me make an observation. For example, in this grid, there will be total three A's, three B, and three C's in total. So let me count the number of A's, number of B's, and number of C's. And there is single character whose count is one, whose count is not equal to three. Then that is a character which is missing. So I will show you this implementation. What I have done, I was simply counting the characters of A, characters of B, and characters of C. And the characters which is not equal to 3, I will simply print that character. So this is a pretty much clean implementation of problem number B. Let's now discuss problem number C. The name of problem is can I square? What they have said, initially we will be given n buckets and the ith bucket contain ai wooden squares of side 1 and we will tell them using all the squares can I make a big square. For example, in this case, in the single example, we have given that I have 9 total 1 into 1 sided square in my bucket 1. So can I make a larger square using using all the blocks? Yes, absolutely. I can make a square of size 3 into 3. In a square of size 3 into 3, where all the 9 boxes will be used. And in this case, you can see 14 plus 2. In this case, I am having total 16 number of blocks. So can I make a bigger square by using total 16 number of squares? Absolutely yes. Why so? Because 4 into 4 is 16, and I can make a square larger square of size 4. So how I can find the answer? If the total sum of my array is a perfect square, then my answer is this, else my answer does not exist. For example, in this case, what is the sum? In this case, my total sum is 36. So 36 is a square root of 6. So the square root of 36 is 6. So in this case, my answer is also existing. But the sum of this array is 8. But 8 is not a perfect square of any number. So in this case, my answer is no. So I have to tell them whether the sum of all the numbers is a perfect square or not and print that. This is only in problem number C. Its implementation is right here. I have taken this function from JFG and direct paste it here and just finding whether a number is perfect square or not. Let's suppose this is it. Now let's discuss problem number D. The name of problem D is Unnatural Language Processing. It is a pretty much implementation type problem. For example, what is problem asking? In problem we will be given a string which will be only containing 5 letters A, B, C, D and E. And my A and E are vowels, not denoted as V. Rest of the characters B, C, D are consonant denoted by C. And they have tell them we have two type of syllabuses. Syllabus you can say there's a type of grammar you can say in this language. And what is a syllabus? Syllabus is a type of word which is made using C and V, means a consonant and a vowel. And it can also be found by using CVC, a consonant, vowel, and a consonant also. Okay, like BA is a CV type, CED is a CVC type, BAB is also CVC type, but A is not among any of these. It is a VV part, which is vowel and vowel, so it is not considered a syllabus. So what they have said that that initially I I had some number of syllabuses in myself, and what I have done, I have concatenated all the syllabuses, and I have to tell them now I have to segregate them again. For example, this is a string of some number of syllabuses, and how to concatenate, how to separate them. For example, I can make it different like BA, CED, and BAB, because you see BA is a CV type, CED is CVC type, and BAB is also CVC type. So I have to place dot between them. So how to solve this problem? So when I solve this problem, I break it onto two parts. How? So tell me what are the valid moves? So tell me what are valid moves? CV, CV or CBC. So a array containing number of syllabuses. How can a syllabus can be formed? For example, I have multiple CVCs like CV, CVC. Now again CV, CV, CV. So now tell me, can two consecutive C occur in a syllabus? The answer is no. So first of all, I will segregate them based on two C's. For example, in this case, we can see, is there anywhere two C's coming? Yes, here two C are coming. So I will place a dot here in my first step. So in the first step, what I will do, I will simply find all the pairs in which my two C's are coming concurrently. So like here, let me make one more example, like CVC again, and CV, CV, C, CV. Right. So first of all, I will find all the pairs in my two C's are coming together. So how many two C's are coming? Here also and here also. So I will segregate them like CV, CV, C, and this is one part. Now CV, 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 C. This is next part, and last part is CV, CV, C, and next CV. So I will segregate all the parts based on the two C's. So now I will deal with this part only. Now I know these individually part are both are valid syllabuses. Why? Because you know there is no consecutive C is coming here. So now tell me, if the length is, for example, what is a pattern in this type of string after segregating them? So now the only pattern left is C. So now only pattern left is CV and CV. Now none of the other sequence can come, because you know my VV cannot come together because it is also not a valid syllabus, and they have given that this is a valid syllabus string made using many number of syllabuses. So my VV cannot come together, right? What is the other configuration? CC was coming, but I have segregated them. So what is the left configuration? The left configuration is only of CV, which means the left of the string will follow a pattern of CV. Okay. So if my pattern is like this, how can I divide them into valid syllabuses? If my length is even, if my length is even, for example, in this case, my length is even, so I can simply divide it into two equal parts. I can make a dot here. Yes, I can make. Now suppose there is another case, CV. Okay, what is its length? Its length is 6 and it is even also. So I can divide it like here and here. Okay, this is a valid syllabus, this is a valid syllabus, and this is also valid syllabus. So there is one observation. If my length of resulting string after dividing them into after this part, if my length of the string is coming to be even, then I will place dot in every two consecutive CVs. Okay, this is the part. But now tell me, if the length is not even, for example, in this first case, my length is not even. So how where I can place a dot to divide into valid CVs? So I will start from starting and place a dot in every corner. I will place it here. Now tell me, I will only left the last CVs. What is the last dot which I should place if it is a valid even length CVs? I should place it here, but I will not place here. I will leave this part. So now tell me, is it a valid CV or syllabus? Yes, you are. I am right. It is a valid and it is also valid. So in next case, I will start reading. What is its length? Its length is also odd. So I will start placing dot from starting. I will make it here. I will make it here. I will make it here. Now tell me, is it is the last dot? Is it the last place where I should place a dot? Yes, but I will not place it here because it is a odd length. What is its length? Its length is also odd. So I will make it here. Should I make it here or not? Because it is the last point where I should make a slash or I should place a dot. So I will not place it here because it is also odd. I will not place it. So let's suppose there is also a number like CV, CV, and CV. So where should I place a dot? I will place it here. I will place it here. Why I am placing here? Because you see the length of this array, this string is even. And in even length, I will not remove the last dot. So this is the whole implementation. So if I show you the code, first of all, what I'm taking the input array, and if my length is initially 1, then I will simply print that single character and return from here. Now what I am doing, I am simply dividing on the base of two C's, where my two consecutive consonant and coming, which means my two consecutive BB or CC or like CB, which means my both the characters are consonant. If this configuration is coming, then I will break it that part, because you see there's a function like if my characters B, C or D and my consecutive characters are of this occurrence, then I will place a dot. I will make a dot here and separate that array. Okay. Now what I'm doing, I'm simply iterating from the starting, and what I'm storing, hey, it is a temp string, but I'm storing in temp. In temp, I'm I'm dealing independently from this string. I'm dealing independently from this string, from this, from this, and last from this. Okay. So in a string named temp, I'm only storing the these individually strings. Okay. Now what I'm doing, I'm simply placing the dots after every 2 points. For example, if this is my array, or I can say this is my string, then I will start placing from starting. I will place it here, place it here, place it here. Okay. I have a place, but there is also case. If my length is odd, let's suppose there is also a C here, and I have placed a dot here, but it is not a valid dot. So what I am doing, I am simply checking if my size of temp is not equal is a even, which means it is initially a odd length string. If it is a initially odd length string, what I am doing simply, I am simply replacing the dot with the next letter. For example, if I will take this as one only. For example, after placing dot, but should this look like? It should look like CV, then dot here, CV dot, CV dot, CV dot, and C. Okay. So now if my temp size is, means it is a odd array, what I will do, I have simply replace the I will simply this character with this character, which means I will make it like I will make it like hit dot and C. I will remove both dot and C and simply place C here. So by doing this, you can observe my last dot is removed. Okay, and my last dot is good. And by processing this thing independently from from two CVs, I simply concatenate in my final answer and print it. Okay, so you can find the implementation below in the description or in the comment section. So let's now discuss the problem number E. So it is a very much greedy, tricky, I can say, or a pre. Maybe most of you have done this problem, but not able to figure it out how to solve this in this contest. So what problem is asking us to do simply, I have to tell them whether there exists a subarray in which the sum of odd indexes is equal to the sum of even indexes. Okay, so this is our problem. What is asking us to do? For example, in this case, it is like 1, 3, and 2. So now tell me, 1 plus 2 is equal to 3. So yes, the whole array is itself good. Now tell me it's this part. So this whole array is also good because the sum of even indexes is also 3 and odd indexes are also 3. So in this case, my answer also exists. So now tell me how to figure out the solution. So there is a prerequisite for this problem. So most of you have done this problem. Like I have an array, I have an array of some elements. These are elements. Now I have to tell them whether there exists a sum array in this array such that its sum is zero. For example, now tell me its sum is zero, right? Means in an array, I have to tell them whether there is a sum array whose sum is zero. First, I would try to solve this problem before solving this problem. Okay. So now tell me. Now I tell you the solution of this part. Simply, I will, for example, my array is like 7, 1, 3, 2, 8, right? Then it is minus 1, 2, minus 3, and 8. Now I have to tell them whether there exists a subarray whose sum is 0. So what I will do simply, I will simply make a map and some and some variable. This is a renowned problem. You can find its code anywhere. So now tell me, I will take a sum variable as 0 and initially a map. So now tell me what is a prefix sum here. The prefix sum here it is 0. Yes. Okay. What is prefix sum here? The prefix sum here is 7 because 0 plus 1 7. Okay. What is prefix sum here? The prefix sum here is 6. Yes. 7 minus 1 6. What is prefix sum here? Here it is again 9. Yes. What is prefix sum here? Prefix sum here is 7. Yes. Now tell me whether 7 is existed before or not. Yes, 7 has come before also. So if my prefix sum repeats, then there is a possibility, or I can say there is a subarray whose sum is 0. Yes, there is a subarray with whose sum is 0. So this is how I can solve this problem, in which I have to tell them whether there is a subarray whose sum is 0 or not. So okay, so this is the whole problem. How can I solve this? How can I solve this problem? So now most of you may be able to solve this problem now, because this is an extension of this problem only. So but how to solve this problem? So to solve this problem, first I will do. Now tell me what they have said. The sum of even indexes should be equal to sum of odd indexes, right? Which means in a subarray, if I minus the sum of odd indexes, if I minus the sum of even indexes from the sum of odd indexes, then it should be zero, right? Yes, this condition is true. So now tell me if I negate all the even indexes number. For example, in this case, it is like 1, 3, 2. So if I negate all the numbers which are on even indexes, like minus 3. So now if I take the subarray sum, if I take the subarray sum, then this come equal to 0. Yes, it is coming equal to 0. So this is our problem solution. First prerequisite is this, that I have to find the whether there is a subarray whose sum is 0 or not by doing negation on all the negative or on the or even number of indexes, or I can make a negate on odd indexes also. It's your choice. Okay, so what is it implementation? What I'm taking, I'm simply negating all the numbers if they are even indexes, right? I will make it up making minus of a of I. Now what I'm taking, I'm making a sum variable and a map and storing the sum occurrence in my map. If at any point my sum is previously existed in my array, here you can see this is what I'm talking about. Now you can see what I'm doing here. I'm making a prefix sum. Here it is at 7. Now at this point 7 again come. Now this means there is a subarray whose sum is 0. That's why the sum is repeating. Okay. If my sum is repeating, which means there is a subarray whose sum is 0. And the subarray sum is 0, which means that there are some points in which my sum of odd minus sum of even is coming equal to 0. Yes, this condition is true. So that's why I can say there is a subarray in which my sum of negative sum of even numbers is equal to sum of odd numbers. That's why sum of odd minus even is coming equal to 0. Right? So I will simply print yes, and if none of the conditions is satisfied, I will simply print no and return. So this is our problem of problem number E. So let's now discuss the last problem which I was able to solve this problem set. It is F greeting. So what they have said, we are giving some I number of persons, and they're on the point, they are on the starting point AI, and they want to go on ending point B of I. And for each person, my A of I is smaller than B of I. Now, what they have said, if at any point two persons meet, for example, if my person one is at this point, my person and he want to go to this point, and there is also a person which is at this point and he wants to go to, let's suppose he want to go to this point 4. Now, if at any point my this person meet with this person, then they handshake, which means they made a handshake. Okay. Now, after tell them what are the total number of handshake in this configuration. For example, and in a single unit of time, they move by 1 unit. For example, there are only one. There's like one. For example, there are three segregation, and here it's like one, two, three, 4, and 5. So in a single point, my this will come here, my this will come here, and this will come here. Now this here, and this here, this here, and this here. Now it will not move further because it has reached the end point. Now if this come to here, now you see the both the person are on the same point, which means they will make a handshake. This means +1. Now it will move further and no handshake will be done. So answer in this configuration is 1. Okay, so I have, so you have understood problem statement. So I will directly jump to the solution, how you can approach this problem. So I will make you understand using this test case. Okay, so first of all I will make the interval in the sorting order by using their size. Okay, I will sort the interval in their sizes. Okay, so what is the shortest interval in this? It is 4 and 5. Okay, so I will make a number line here like 1, 2, 3, 4, 5, 6, 7. These are the starting and ending point of all the numbers, 8, 9, and 10. Okay, so what is the smallest sequence? My smallest sequence of 4 and 5. Okay, 4 and 5 here, starting and ending point here. Okay, so let's suppose make it rough only. My first is like here, and he wants to go it here. Okay, and my second number is here, and he wants to go to this number. Okay, yes, my this number is here, and he wants to go to here. Okay, my this is here, and he wants to go to point number 8. Yes, my this point is 7, and he wants to go to point number 10. Point number 10, right? And there is a last one which is -2, and he wants to go to -100. Let's suppose these are -2 and this is 100. Okay, so how many handshake will be there in this configuration? So now tell me, if a number is ahead of my current number, for example in this case, my this number is previous, and this number is ahead of this number. So can they make a handshake? No, I think so, no. But there is a condition. For example, I will tell you some test cases. Like if my person is here and he wants to go here, and if my another person is here and he wants to go to here only, behind it only, so they will make a handshake. Yes, why so? Because you see, at a single point, my this person will go to here, and this will come here, this will go here, this will come here. Now at the next point, it will come here, which means they will definitely meet. Okay, they are meeting here, which means if at any point my if my configuration of first number is like this, and there is another number who is starting ahead of this, and who is ending behind of this, right? Then they will definitely make a handshake. That's for sure. Okay, so this is the condition number one. So now tell me, if my configuration is like this, my number two. So with how many numbers, or I can say with how many numbers will this make a handshake? So I will make a configuration like here, which means how many numbers are there which are coming in this range, which are completely summarizing in this range. So it is only one number, which is 4 and 5, which means my 2 comma 6, which is my this number will only make a handshake with 4 and 5. Okay, so +1 for my this one, right? So now tell me another case. My string number 2. How many handshake will make this number? The sequence of this is this. So how many numbers are completely summarizing in this? It is only one here only. Yes, it is plus one, right? Okay. Now coming to the next part. How many of for this? I think so none of this because none of the interval is completely summarizing in this. So not anything, right? So how many in this? So yes, how many for this? So there are total two intervals which are completely summarizing in this. The interval number this, by this interval and by this interval. So 4 plus 2 for this part. Okay, yes, right. So now next, what are the remaining left? My next number is this. So with how many numbers will this make a handshake? So now tell me whether there are any interval which are coming in this. I think so not. None of this is coming. So answer for this is 0 also. So now last part. How many strings which are coming or interval which are coming in this sequence? Which are coming in this sequence. So they are total 1, 2, 3, 4, 5. So they are total 5 sequence which are coming in this interval. So answer for this is 6, 9. 5 plus 2 plus 1 plus 1, 9. So you see my answer is also 9. Right? Okay. Now tell me another case. So let me debug one more case for you. Let's suppose taking this example. I will come back here later for making better understanding. So in the meanwhile let me debug this test case also. Okay. So what are the intervals like minus minus 9 to minus 4 to here 9. Okay, and here it is like minus 2 to 5. It will end before only. Yes, 3 to 4 and 3 to 4, 6 to 7. 6 will start it from here and end it later. Okay, this is 8 only. 6 to 7. Okay, now last it 8 to 9. So 8 to 10, sorry. Yes, so it will start. Maybe I should elongate this to 9, and my the last sequence which is 8, it will start from here and it will end 10. So how many possible numbers are there? So what are the possible numbers which are summarizing in this part? So they total 1, 2, 3. So they total to plus 3. I will do it here. Okay. Now for the next part, how many for this part? So they total 1 only. So I will do plus 1, single one. Okay. Now for the next part, for this, I think so none of the sequence is summarizing in this. So 0 for this. Okay. For this, the answer is also 0 because none are summarizing in this. 0. So for this, how many are there? Here to see there is coming, but it is not completely summarizing in this interval. So for 0 also, for it's also 0. So what is the answer? Answer is 3 plus 1, 4. So you can see answer is 3 plus 1, 4. So how to solve this problem optimally? First of all, what you can do, you can simply sort the intervals in terms of their increasing sizes, right? How to sort? Let me tell you. Let me debug this test case in the according to their sizes. So what is the smallest? Smallest 4 comma 5. Yes, 4 comma 5. Yes, what I will write a difference here. Like difference is 4, 6, 1, here it is 7, here it is 3, and here it is some greater number. Now tell me if this is done, what is the next greater? It is 3, which is 7 comma 3. 7 comma 10. So 7 comma 10. 7 comma 10. Okay. Now what is next? 4, 2 comma 6. From 2 to part number 6. From 2 to 6 part. Yes, it is here. Okay. Now what is next? It is 3 comma 9. Yes, 3, where is 3? And where is 9? 9 is simply here. Okay. So 3 comma 9 and 1 comma 8 at the end. Here it is 1 and at the end it is here. Okay, and what is the last part is this, which is from -2 to 100. So simply what I was doing, I was simply calculating all the numbers, all the sequences which are under this. So I will do a reverse because reverse is also true. What I am doing now, I will simply start from the smallest one and try to find in how many sequence can this interval can be completely summarized. For example, for this, in how many intervals this is completely summarizing. There are total one, 2, 3, 4. Total 4 intervals. Yes. Okay. For the next, in how many intervals is this completely summarizing? I think so only one, because you see in this interval it is completely summarizing, it is last one. So plus one for it also. Okay. So now for this part, in how many intervals it is completely summarizing, it is also plus 1, plus 2, sorry, plus 2. Okay. Now for the next part, that is my this interval. In how many part is this coming? So that is only one, and that is the last part, which is this. For plus 1 for this also. Okay. So and the last part, which is this. In how many interval is this completely summarizing? Which is my last sequence, which is plus 1. Okay. And for the last it is none. So what is the solution? 1 plus 1 2 plus 4 plus 4 plus 1, that is 9. Answer is also coming 9, which means what I will simply do in my solution, I will simply try to find, I will simply sort the sequence according to their sizes. Okay. Now what I will do, I will simply check in the next array, which means I will simply check in the downwards type, in how many parts my this sequence is completely summarizing, which means how many intervals are there such that their starting point and their ending point are greater than my, which means their starting point is smaller than my current smaller point, and their ending point is greater than my current ending point. So I will try to find that part. Okay. So how to approach this, or how to implement this part? So we can easily implement this part using a ordered set in C++. I don't know about Java, so I will show you the C++ code here. Because implementation is this, or I can say intuition is this. First of all, sort the intervals according to their increasing sizes. Now for the particular interval, check how many intervals are there in which their smaller part is smaller than my current text and their larger part is larger than or greater than my current text, and count them and store the count in my interval. So because I have sorted them, so I will only see in the next part of the array. Because you see, the only increasing interval which I can achieve is in the next array, in the next part of the array also. So that's why I have sorted in the increasing order. So if I show its implementation, so what I am doing here simply, I'm simply using a ordered set. You can study this about in C++. So I am simply, it is a type of classical problem of ordered set. So it is a here, so its implementation is here. I am simply pushing the starting and ending point and ending a starting point. If at any point I am getting a starting point of my array, then I simply print the starting point. Now, if at any point, if I'm coming to the same position again and getting its ending point, then I will simply find the number of values which are smaller than or equal to my current text using an ordered set and plus the minimum answer and print that. So you can find the code in the description. So if you have any doubts in these problems, you can comment me down. Until then, stay tuned for the next one. Thank you, and please don't forget to subscribe my channel. So thank you.